Welcome to have you here. Mobility House is a startup company, not anymore. We are existing 10 years in the market, and we believe in bringing the renewable world together with the automotive world. So bringing batteries together with renewable energy. Because we think batteries in the mobility world will be more and more electric vehicles with batteries, and the renewable world will be more and more volatile and needs batteries to compensate. So what do? We start small, we integrate vehicles charging at one place so that they charge smart, that they don't overload the grid. It's a hardware neutral, hardware agnostic product. So we have a local controller, that's the orange part you see there in the back, or you can see it here. You can connect via a switch as many charging stations to that local controller so that we control the charging of electric vehicles smart, so that you don't need any grid extension, or to the largest extent. At a certain moment also an algorithm can't kind of optimize things anymore. We also avoid grid extensions to a certain extent, which is very time consuming and very lengthy. This is all open standard based, so we don't trust in kind of closed shops. We want to have open standards. We want to have interfaces to all different kind of charging manufacturers. So no matter if you go to ABB or if you go to EBG or other players in the market, being it Delta in China or BTC in the US, that you can connect them all as soon as they speak the OCPP standard. And we don't stay behind the meter. We just with charging, we also integrate a building load. So if you have a PV system on your roof, also a solar system feeding into your building, so we would charge when there is sun energy from your roof fed into the building. We would also charge then if you have a battery storage in combination with the battery storage, so that we shave peaks. And this is the basic things we can do already today, because this is behind the meter in a regulatory framework which is existing. But we are also looking ahead to the future. We believe that cars in the future will be bidirectional and will be part of the energy grid. What we achieved last year with our software, we together with Nissan, we pre-qualified a Nissan Leaf as the first electric vehicle officially within the European Union as a power plant. So the whole software is safe and secure, that it's accepted by the European Grid Agency, the NZOE, as a control for an electric vehicle in the grid. And we believe in the midterm future, all electric vehicles with their batteries will be part of a premises, a building, but also to the total energy system. So this in a very brief. Today's use case mainly is balancing the load, and the future will be creating value by integrating electric vehicles into your grid. Any questions from your side?
Is there a standard coming up for vehicle to grid? Also not for Nissan Leaf, maybe?
Yes, so vehicle to grid is currently just applicable for the CHAdeMO standard, so mainly the Japanese car, mainly the Nissan Leaf, because they have a big battery. The Mitsubishi battery is still a little bit slow, but there is another standard for CCS, it's 15.11.8, the edition 2 upcoming. It's heavily discussed, and I think they need another, let's say rather 2 years than 1 year, but it will come. And if you listen to, for example, Volkswagen closely, their MEB platform will be applicable to V2G already, and also all the other car manufacturers look at it and discuss it, but haven't announced anything officially. So for sure it will come. They will focus more on a local self-consumption optimization than on being part of the huge energy grid, but this is kind of a step-by-step evolvement. For example, with that software we control close to 3,000 batteries, second life and first life vehicle batteries we put in different areas, in a hall, in the Amsterdam Arena, for example, or in Berlin, in a commercial building. We treat them as they would be 2,500 cars and do certain energy products with them. And in average with those batteries, and these are small batteries, 20 kilowatt hour batteries, we earned last year 1,100 euros per battery. So imagine the future, and this is what we believe, will be zero emissions, because most of the world will drive electric and fueled by renewable energy from your roof, from wind on and offshore. But it will also be zero or nearly no costs, because if you charge at the right time, there will be always overcapacity. So we already in Germany curtail wind for 5 terawatt hours because we don't know where to bring that wind energy. We do not have the grid connection to the south. So this is about 2 million cars with 15,000 kilometers a year you could charge for free. And the more the system gets CO2 free, the more kind of renewable energy we integrate, the more you need storage, and an electric vehicle is an ideal storage.
Can you show and explain, please, what we see there on your wall?
Which wall? So what you see here is the local controller, which controls as many charging stations as you want to have, as soon as they speak OCPP 1.6 standard. You connect these charging stations via a switch and via LAN cable. You can also have Wi-Fi, 4G, whatever. They are also connected to a meter to get the building load, or connected to a PV system or a local storage system, so that we integrate renewable energy from your building to charge the cars, or that we do not exceed the grid limit of your building while charging those cars. So you connect then the charging stations with a LAN cable to that. It's hardware independent. Whatever charging station you use, as soon as it speaks the certain standard, you can integrate it. And you can control a complete parking garage, or if you have a smaller parking space, totally does you. Also with it comes a back-end system where you get alert messages if one of your vehicles isn't charging. For example, if you are a logistic provider, charging is a vital action, because if your vehicle isn't charged in the morning, you can't deliver any parcels. So you need to have a back-end system with alert messages that if there is any failure, a fuse trips or whatever, you get an immediate information. Oops, I have an issue, and you look at it, you look into the dashboard and see, okay, I have to send my electrician there, or I have to restart my Wi-Fi module, or things like this.
Thank you so far. Are there any questions? That would be great.
I was wondering if you could elaborate more about the savings that you said that 1,100 it's possible to save. Is it from selling electricity back to the grid, or is it coming from the peak shifting, or where is it?
So these 1,100 euros we're referring to these close to 3,000 batteries we market in the European energy market. The savings here, just to give you an example, we have a customer here in Munich. It's a nursery caretaking company. They have 10 electric vehicles. They needed to extend their grid, and they all arrive at 5 in the evening till 7 in the evening. They would all start at the same time. If they would do uncontrolled charging, they would have additional cost over 10 years of 120,000 euros, so 12,000 euros a year. This is combined by a one-time fee investment cost into a stronger grid, so a grid extension, and the yearly fee or monthly fee you have as demand charges, because in most of the countries you are charged by the highest peak you create in a 15-minute period, and that highest peak you charge for the whole year. So if you want to have all cars coming at 7, all starting at the same time, you would pay kind of the highest rate. This we avoid, and for a company with 10 vehicles in Munich, it depends on countries and regions, because grid operators are locally operating. we save them 120,000 euros. To invest into intelligence by charging vehicles is always a business case, always.
Thank you very much.
You're welcome. Great to have you here. Have a nice fair, have a nice trip here, and enjoy Munich.